It is not code compliant to install high-intensity discharge, or HID, fixtures wired for 480 volts in a school building. The National Electrical Code, or NEC, sets specific requirements for lighting in schools to ensure safety. A critical aspect of these requirements relates to the voltage levels permitted for lighting circuits. The NEC mandates that lighting fixtures in schools must be connected to either a 120-volt circuit or a 277-volt circuit. This limitation is designed to reduce the risk of electrical shock and fire hazards, given the presence of students and staff. The rationale behind restricting the voltage to 120 volts or 277 volts is related to safety considerations and the potential for accidents. High-voltage systems, while potentially more efficient for certain applications, present a greater risk of severe electrical shock and arc flash incidents. In an environment like a school, where there is a higher density of people and a greater potential for accidental contact with electrical equipment, the NEC prioritizes low-voltage systems for general lighting. The NEC also addresses the use of HID fixtures on 480-volt circuits. It stipulates that HID fixtures can only be connected to a 480-volt circuit if they are part of a listed assembly specifically designed and approved for use on a 480-volt circuit. This requirement is intended to ensure that all components of the lighting system are properly matched and certified for safe operation at the higher voltage level. A listed assembly, in this context, refers to a complete lighting system that has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or UL, or Intertek, or et al. The listing ensures that the fixture, ballast, wiring, and other components are designed to work together safely at 480 volts. Without this listing, the installation would not meet code requirements and could pose a significant safety risk. The term listed in the NEC has a specific meaning. It indicates that a product or assembly has been evaluated by an independent testing laboratory and found to comply with established safety standards. These laboratories conduct rigorous testing to verify that the product meets the required performance criteria and safety standards. The listing process involves not only testing the product's performance but also inspecting the manufacturing facility to ensure that consistent quality control measures are in place. The NEC requirements for HID fixtures on 480-volt circuits are based on the potential hazards associated with high-voltage lighting systems. Firstly, the higher voltage presents a greater risk of electrical shock. If a person comes into contact with a live 480-volt circuit, the severity of the shock can be significantly greater than with a 120 volts or 277-volt circuit. Secondly, high-voltage systems can generate more intense arc flashes, which are explosive releases of electrical energy that can cause severe burns and other injuries. Thirdly, the risk of equipment failure and fire is higher with improperly installed or maintained high-voltage lighting systems. To ensure compliance with the NEC and minimize these risks, it is essential to adhere to the code's requirements for lighting installations in schools. This includes using only 120 volts or 277 volt circuits for general lighting and ensuring that any HID fixtures connected to 480 volt circuits are part of a listed assembly specifically approved for that voltage. When selecting lighting fixtures for a school building, it is important to consider the specific requirements of the NEC and any local building codes. It is also advisable to consult with a qualified electrical engineer or licensed electrician to ensure that the lighting system is designed and installed in accordance with all applicable regulations and safety standards. In addition to the NEC requirements, local building codes may impose additional restrictions or requirements on lighting installations in schools. These local codes may address issues such as energy efficiency, light levels, and emergency lighting. It is important to be aware of and comply with all applicable codes and regulations to ensure a safe and code-compliant installation. When installing HID fixtures on a 480-volt circuit, it is essential to follow the manufacturer's instructions and recommendations carefully. This includes using the correct wiring methods, grounding techniques, and overcurrent protection devices. It is also important to ensure that all connections are properly made and that the system is thoroughly tested before being put into service. Proper maintenance is also critical for ensuring the continued safe operation of HID lighting systems. This includes regularly inspecting the fixtures, ballasts, and wiring for any signs of damage or deterioration. Any damaged or worn components should be replaced promptly to prevent potential hazards. In summary, installing 480 volts HID fixtures directly in a school building is not code compliant. The NEC mandates 120 volts or 277 volts circuits for general lighting in schools unless the 480 volts HID fixtures are part of a listed assembly specifically approved for that voltage. Adhering to these requirements is essential for ensuring the safety of students, staff, and the building itself. Always consult with a qualified electrical professional to ensure code compliance and safety. The National Electrical Code provides comprehensive guidelines for electrical installations, including lighting, to ensure safety and proper functioning of electrical systems. It's important to understand the specific sections relevant to lighting in educational facilities such as schools. These sections address voltage limitations, wiring methods, and equipment requirements. Voltage limitations are a primary concern in school settings. The NEC generally restricts the voltage for lighting circuits to 120 volts or 277 volts. This restriction is in place to minimize the risk of electrical shock to students and staff. Higher voltages, such as 480 volts, are typically used for industrial or commercial applications where the risk of accidental contact is lower. Wiring methods are also crucial for ensuring safety. The NEC specifies approved wiring methods for different types of installations. In school buildings, wiring must be installed in a manner that protects it from physical damage and minimizes the risk of fire. Conduit such as rigid metal conduit or electrical metallic tubing is often required for wiring inaccessible areas. Equipment requirements are another important aspect of the NEC. The NEC sets standards for the design and construction of electrical equipment, including lighting fixtures, ballasts, and transformers. These standards ensure that the equipment is safe to use and will perform reliably. When installing HID fixtures, it is essential to use listed equipment that is specifically designed for the intended application. In addition to the NEC, local building codes may impose additional requirements for electrical installations in schools. These local codes may address issues such as energy efficiency, emergency lighting, and accessibility. It is important to be aware of and comply with all applicable codes and regulations. Proper grounding is also crucial for electrical safety. The NEC requires that all electrical equipment be properly grounded to provide a path for fault current to flow back to the source. This grounding helps to protect against electrical shock and prevent equipment damage. Grounding electrodes such as ground rods or metal water pipes must be installed in accordance with the NEC. Overcurrent protection is another important safety feature. The NEC requires that all electrical circuits be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to interrupt the flow of current if it exceeds the safe level, preventing overheating and potential fire hazards. The size of the overcurrent protection device must be properly matched to the ampacity of the circuit conductors. In addition to these general requirements, the NEC also has specific provisions for lighting in educational facilities. These provisions address issues such as lighting levels, control systems, and emergency lighting. Lighting levels must be adequate for the tasks being performed in the space. The NEC provides recommended lighting levels for different types of activities such as reading, writing, and assembly. Control systems can be used to reduce energy consumption by turning off lights when they are not needed. The NEC encourages the use of occupancy sensors and other control devices to minimize energy waste. Emergency lighting is required to provide illumination in the event of a power outage. The NEC specifies the minimum lighting levels and duration of emergency lighting. Emergency lighting systems must be tested regularly to ensure that they are functioning properly. When working with electrical systems, it is important to follow safe work practices. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Never work alone on electrical systems. If you are not qualified to work on electrical systems, hire a licensed electrician. Regular inspections and maintenance are essential for ensuring the continued safety of electrical systems. Inspect electrical equipment for signs of damage or wear. Replace damaged or worn components promptly. Test overcurrent protection devices regularly to ensure that they are functioning properly. Keep electrical panels and equipment rooms clean and free of obstructions. By following these guidelines, you can help to ensure the safety of electrical systems in schools and other educational facilities. Remember that the NEC is a complex document, and it is important to consult the codebook directly for specific requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Furthermore, it is important to remember that the installation must be in accordance with the manufacturer's instructions, which typically are included with listed products. These instructions are part of the listing requirements. Not following the manufacturer's instructions invalidates the listing. It is also important to note that simply being part of a listed assembly is not the only requirement. The assembly must be specifically designed and approved for use on a 480-volt circuit. This means that the assembly must be tested and certified to meet the safety and performance requirements for 480-volt operation. Some assemblers may be listed for use on multiple voltage levels, but it is important to verify that the listing specifically includes 480 volts. In conclusion, when considering the installation of HID lighting in a school building, the primary concern must always be safety and compliance with the National Electrical Code. The NEC clearly outlines the permissible voltage levels and conditions for HID fixtures, and these requirements must be strictly adhered to. The use of 480 volts HID fixtures in a school is generally not code compliant unless they are part of a specifically listed assembly designed for that voltage. It is essential to consult with qualified electrical professionals to ensure that all installations meet the necessary safety standards and regulations. Ignoring these codes not only puts individuals at risk but also carries legal and financial repercussions. Therefore, prioritize safety and compliance when dealing with electrical installations in any setting, especially in places where children and vulnerable individuals are present.